Welcome to Tank Settlement 101. We're going to do the class not with the laser scanner, but with the total station. Okay, so we have three technologies available in our wheelhouse. That is, we have a laser level, okay, we have a total station, and we have the laser scanner. Okay, so laser scanner is obviously the most advanced. Okay, but the total station is just as accurate. It's a little bit less advanced, but it's more practical and it's doable in the field, and the results are with you on site, right? Versus laser scanner, you do the whole scan, you go in a computer, you fetch the dots to where you need to, then there's a delay of the post-processing. Okay, total station is my favorite because it's a very versatile machine compared to the laser level. Laser level is very limited in terms of if you have a really difficult congested area, or the tank is way up there because the foundation is designed in a certain way, laser level is just difficult. For example, if I draw a tank like this, and basically if there's a little bit of a, like height, right? So if we do it from the outside, the laser level is going to be a pain because the laser level can only scan like this, right? Versus if we're doing internal scan, laser level works just fine because it can just do the measurements from inside where everything is flat. Whenever there's height challenges, it's pain in the ass. Okay, so before we learn to how to operate that machine, okay, I want to explain that, just recap a little bit on what is it that we have to scan. Okay, I want to start with external. Okay, so for a tank, before we go on to external, okay, so there's this for a tank. There is the edge settlement. Okay, and there's the shell settlement. Okay, so the edge settlement, you need the information not only at the shell, but also at the floor. Okay, so you have your, let's say that this area is experiencing some sort of settlement right here. Okay, so you need the information here, but also here, to see if there's any settlement going on. Correct? Yep. Can you picture that? Yep. Okay. Then there's another type of settlement, which is the shell settlement, right? This is where you have the tank, and you basically have all the readings all around the shell. Okay. With that information, when you put it on Excel, right, you could tell if the tank is flat, if the tank is a little bit tilting, right? If the floor itself is warping, right? If the floor is a little bit warped or not, right? So you can tell all that. Not the floor, but the edge, but the you can have a tilt or you can have a warp, correct? You can tell all of that from just the points at the edge. Does that make sense? Mm-hmm. So there's two types, the edge settlement and the shell settlement. Okay, so okay, this is the top view of the tank. Okay, so for shell settlement, we need points here, 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 and so on, right? For shell settlement, for edge settlement, you need there, 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 you need there. There, 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 there. Does that make sense? So mathematically, you have a representation of a web. Okay, if you just imagine a web and a mesh, that's what we can get, right? With all these dots. How many locations, how many dots, we won't get into that, because that we just have to consult the book, the code. There's a formula set for that. AccuTank does it automatically for us. You don't have to memorize it. This is the simple part, right? So I'm just showing you the concept, okay? But the detailed number and everything, we can look it up later on, all right? So if you're outside of the tank, which one of the two can you do? But you're outside of the tank though. You are here. You can only do your shell settlement. You cannot do your edge settlement for if you're outside of the tank. In other words, when you do in-service tank inspection, the only settlement that we're looking for is the shell settlement. Okay? So this is for in-service, and this is for out of service, and also this is also for out of service, right? Out of service gets both of them. In service gets only one of them. Agreed?
Yep.
With the total station, we also can do one more thing. I just want to, because we're going to go into that, the machine also has the capability of measuring distances. It can measure, like the vertical distance. It can also measure horizontal distance, right? So if you have the shell wall, okay, so this is the floor and this is the wall, and if you're able to measure all these distances, you would know if it is straight or bending this way or bending that way, right? Or if there's a little bit of a dent here, you would be able to know. Okay, so the good thing about the total station, it can measure the X components and Y components separately, right? So if you have all the X components here, so if you have all the X components measured, right, from a reference point, right, if there's a dent, you would be able to tell that, right, from these measurements, right? So it has that capability as well, which is called, for tanks, we say shell deflection or shell, there's a one for the shell plumbness. You got to measure the plumbness, right? So there's plumbness requirements. You can only go tilt so much, there's a limitation, right? So for plumbness, you can use the total station to do those measurements as well, okay? But that's for later on, right? When I train you with the operation of the total station, I have no doubt you'll be able to figure it out by yourself, okay? So one thing is that there is a challenge when we measure it from the outside, right? If we have to measure all these 8 points from the outside, what is the challenge, you think?
Well, you're not dealing with one flat surface to do all. You're potentially up and down all the way around the tank.
Yeah, true. The other problem is that you cannot see all the points from one vantage point, right? You can only see this much, right? So then you have to move, measure again. Then you have to move, measure again. Then you have to move and move and move and so on to measure again, okay? The way the total station measures it, okay, it does not give you an absolute measurement. It gives a relative measurement, okay? So, for example, if you're inside here, okay, I'm saying that I'm the total station right here, and all these heights are relative to me as the total station. Okay, so let's say that the total station, I set it up at 3 feet height. Okay, so over here is going to be negative 3.1. I'm just making it up. Okay, here's also going to be negative 3.1. Oh, maybe there's a little bit of a dip. Negative 3.2, negative 3.3, negative 3.1 again, and so on. When we normalize everything, because it's all relative, okay, it doesn't matter if it's 3 or 10 or whatever. If we normalize everything, it becomes 0.1, 0.1, 0.2, 0.3, 0.1, and so on, right? We just get rid of the 3, okay, because it doesn't matter. The number is against each other, not relative to the total station position. So if I can see all my points from one location, it's dandy, it's simple. Okay? But the moment I move my total station, now that 3 feet measurement is gone, right? So how are we going to deal with that?
Ideally, if you had a tank that doesn't have a center column, you could put it right in the center of the floor.
Let's say that we have to move. We don't have a choice. What are we going to do about that?
You have to create a reference point somewhere.
Yes. What's the idea? How can we do that?
Start from your manway and measure up a certain height from the manway. Mark that as your point, center of manway.
We stopped where? I asked, what if I have to move?
Yeah, you're
right?
looking at what are...
So every time, the total station is literally a millimeter accurate unit, right? So it's really important when you set it up, it's not moving at all, okay? If by mistake you pushed it a little bit and it moved a little bit, we have to redo the whole thing again, okay? So obviously now the total station is set here with fixed known coordinates. We don't know the exact coordinates, we don't care because it's all relative, but it's fixed, right? So the moment we move somewhere else, it's completely different now. No matter how flat the surface is, it's never going to be the exact same. Okay? So what you said is right. We can set a reference and compare it to that reference and do plus minus. You know what's the easiest thing to do? Okay? The easiest thing to do would be to measure that one spot one more time. Okay? So, meaning from your position number 1, it becomes, let's say that you can measure these 3 locations, okay? So let's say 3.1, 3.1, 3.2, okay? For whatever reason, there's a column here and you cannot measure it there, okay? So you have to move it to this location to measure it. All you have to do is measure this point again. So from the new point, it becomes 2.7 and 2.7 and 2.8 and so on. Okay? So now this guy becomes your reference point. Okay? How to do the subtraction and all that stuff, I can show you later on, but just know for reference, you don't have to find another third point as a reference. You do whatever you can, but the last point, when you know you have to move, when you go to the new point, measure that one again, then carry on, then carry on, then carry on. Okay, cannot do, that's the last one. Okay, you stay there with the pole. Hold on, I'm just gonna move. I just moved. You still there? Still holding the same? Okay, measure. I have the new number. Okay, now you go to the next one, to the next one, to the next one. Does that make sense?
Yep.
So when we're doing from the outside, let's say that these are the ones we got it, we got it, we got it. We cannot see that anymore. So we move here, right? From here, we got to measure this one again, then this one, then this one, right? Vice versa. When we go here again, we measure this one again, and then this one, and then this one. Then from here, we measure this one again, and this one, and this one. This is how we complete the circle. Simple?
Yep, makes sense.
Okay. So now we know how to do referencing when we are moving to a new vantage point.
Okay.
Okay? That's all. in terms of concept, that's all you need to know. All right. How many stations? I have a procedure. You can just open up the book for the procedure and you can draw it out.
Okay.
Okay. Just know that any tank below 77 feet diameter is 8 stations. And it always increases by an increment of 2. So if not 8, then 10, then 12, then 14, then 16, then 18, blah, 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 all the way up. It never increases by 1. Okay? Demonstrate how to do it. Do we have a clear understanding on what do we have to measure?
Yeah.
We do, right? Now, let's see how we're going to do it.
Sure.
Okay? So for our, we use the Sokkia SRX 3. This is called a robotic total station by Sokkia. This is the package. So we have 2 orange boxes and the tripod and the pole over there. Okay? So we're going to set it up first. Step number 1 is going to be setting up the tripod with the spreader bar. I'll show you how to do that. So here's our tripod. And there's a pole inside. This can wait. Okay, let's wait for this one. Make sure that this is tight. There's a screwed element. The pointy tip is screwed, and this one can be changed. The height can be changed. Okay, but that's okay. We don't want to do that now. Let's leave it back here. Okay, let us set up the tripod. So we want to, so there's a, this is called a spreader bar. So if we're in a rocky area or a soil area, we don't need to use that, right? But if you're inside a tank, I mean, in the rocky area, you can do it as well. It just makes it nice, you know, like same angle. You can use it, but sometimes if one end is a little bit high, you cannot, then don't use it, okay? So we want to make it comfortable for our height. For the tripod, it's somewhat, like this is a good height, you know? So you can clamp. Okay, lock it down. Can you put that hole into that? There you go. So this is a comfortable height. If the total station is here, like it's at a comfortable height for us. Yeah. So I'll repeat that because I wasn't in the frame. Okay. So what Abdul does is put something here to see if it's flat or not. If it's grossly misaligned, you can adjust them, and you want to make it somewhat flat. Yeah. You don't have to go to precision flatness yet. It comes on later on. Okay. Okay. We will now go through our total station boxes. So that's our total station. And that's our other thing. So what I would like you to do is that if you grab that total station and put it up here, please. Okay. So put it somewhat in the center and then tie it up from the end. See if it bites in. You might have to wiggle it a little bit till you get the first bite. Did you get the bite? Yeah. Okay. It's all good, right? So now is the second layer of leveling. You see these 3 adjustable screws there, right? Take a look here. This one is really, oh no need to do that. No, we should not do that once it's mounted. Once it's mounted, we should just, yeah, let's lock it up. See what's happening? Yeah, let's lock it up. Yeah, so that once it's mounted, we don't touch these again. Okay, so now you can come over here, please. You see the gap between here?
Yep.
See the distance here
Make sure that-
versus see the
Right.
distance here
Yep.
is different, right?
Yep.
So what I like to do is that make them all the same, which is basically till the first notch. Till the first notch. Yeah, there you go. That's it. Okay. So to do the leveling, we don't play with all three at the same time.
Right.
We align it with one triangle, like a triangle. Okay, we align it this towards us, and those two on an angle like this. Okay, so this one tilts the unit in this axis.
That's right.
And those two in tandem does this way and this way. Okay, so try to understand this. If these two, if these two, we rotate both of them in one way, it's not gonna tilt,
Right.
right?
Straight.
So if one goes up, the other one has to go down,
Right.
right? So that motion is really important. Okay, so you know what, the level is here, so it'll make sense for us to do it like this. Yeah, it'll make sense for us to use this as one and those two as the other. Does that make sense? Does that
Just
make
trying
sense?
to see where the bubble was. Yep.
Yeah, so you see the bubble? The bubble is tilted to the left, right? Okay, so that means the total station is like this, right? Because the bubble is going that way. So it has to go back straight. Okay, so what we need to do, if you start filming me, can you see my fingers? Okay, so we either go this way or this way. We do not go this way or this way. If we go both twisting that way, they're the same direction, both of them together going up or down. But if we go this way, then it's either going this way or this way, right? So always remember this motion. This is the motion. This is the right motion. This is the wrong motion. This is the wrong motion. This is the right motion. Okay? So I can see it right there. So, oh no, it's making it worse. So the other way, other way, other way, other way, other way, other way. So right now it's right at the center, right? And then we play with this. Done. Okay. Do you want to give it a try?
Sure.
Okay, so I'm just going to destroy the alignment altogether.
Okay.
Okay, alignment is gone. I want to see your action. So you should not touch those two at the same time. Oh, you're baselining it.
Yeah.
You're baselining. Gotcha. Gotcha. Okay, good stuff.
So what's determined? Oh, so then I would be right over here then.
Sure,
And I'd use
sure.
these two to.
No. You don't use those two, right? So you'd like to use those two. You'd like to use those two, and this one separately.
Right.
Okay, this will be your
That way. Yeah.
axis,
Okay. Yes.
and the
Gotcha.
other two will be your axis this
Yep.
way, right? Bingo. Is it making it worse or better?
Worse.
There you go.
You wanna do this one?
Yep. Done. Boom. That's it. As long as it's somewhat within that circle, that's good enough.
Okay.
Done. Simple.
Great.
Simple. That's half of the work.
Yeah.
That's half of the work. Okay. So now we're going to turn it on. Okay. Unfortunately. Okay. So you can see there are two holes there, right? Mm-hmm. And there are two pins over there, right? So the holes will go into the pins. If you can feel me. It'll secure right in, okay? So yeah, it went in, but obviously it wants to tilt back. So we place this phone. Do you have another phone there? Or
Oops.
yeah, we just place the foam here as some support, and we put it in. Done. Okay. I don't know why sometimes starting for the very first time it struggles. Okay. So press and hold a couple. Okay. Sometimes it doesn't. So keep pressing for a few times till it boots up. Okay. And now we go to the good stuff. There we go. So I'm just going to destroy the balance. You did such a good job. Do you have a pointy pencil or something in your pocket?
No.
Do you have a pen?
Nope.
I need a pen. I can use this. I can use this. Okay. So it's touch sensitive, and you can work it with a pen. Okay. So you see right there. You see right there with the
cross
with the T.
Yep.
Okay. It shows that it is in balance right now. Let's click that. Right. It's showing that it is in balance. Maybe it can be balanced a little bit more. Okay. Would you like to balance it a little bit more?
Sure.
Go ahead. Isn't that nice? Isn't that just super precise? Okay. Now destroy the balance. Just destroy the balance. I want to show you what happens when the balance. Okay, done. So when we close this, it won't let me measure because it's just going to say out of range, and it's going to show that yeah, it's tilted, right? That's how it's supposed to be when you open it up. But you did such a good job balancing on a crude level. It just didn't prompt you here. But typically when you turn it on, typically it would prompt you there. Then you click on to this, and then you do the balancing. Are you baselining it first?
Yeah.
Okay. Good. No, I think it'll be the other way. I think it'll be the other way. You gotta imagine like a bubble, right? No, that's not done yet. Keep going. Keep going. There you go. There you go. Yeah, now touch the other one. Yeah, then do a little bit more tuning. There you go. So if it's not improving, take a moment to think which way you should be tilting. For this is a bubble. Take a moment to think about which way you should be tilting. Okay, to do that, right? Sometimes you feel that, oh, it's not coming back, then all of a sudden you see that coming back.
Right, going too much.
Right? Okay, so this is good. Let's close it. Let's close it. Okay, so there are 3 tabs here. This is called SHV. This is basically all the angular measurement. We don't care about angular measurements, okay? Our holy grail is this one, okay? Distance, not the angle, okay? Oops. Okay, I press something. Whenever I press something stupid, when we don't know what we're dealing with, just close it. Okay? If you're absolutely out of bounds, like we don't know exactly where we are and you don't have nothing to close, just pull out the battery.
Okay.
Okay? It's not worth going into the menu and going into all that trouble, okay? So you go to SVH distance. Okay? So when we do that, see the three distances, the S, the vertical, and the horizontal. Those two came up. S, don't give a shit. We don't care.
Okay.
Okay? It's the vertical and the horizontal most of the time. For settlement, what do you think we have to measure? Horizontal measurements or vertical measurements?
Vertical.
You're right. Okay, I'll take this call. It's okay, just hold on. So now that it is done, so there are multiple modes, which is right here. Do you see this crystal -7?
Mm-hmm.
That is the mode that we have to use when you're using the pole, okay? But we can change it. There is a blue screen mode. There is a laser hitting the wall mode. There is a red screen mode. There's a red screen with a 30 mode. And we're back at the crystal with -7. That -7 means something about the size of the crystal. What is the distance from the center of the crystal to? So there are some things that we don't need to know about right now. That's not important, okay? But remember, when we use the pole, okay, this is the model we are using.
Okay.
Okay? And you see that little dot there?
Mm-hmm.
That turns the laser on. There's the laser. Right? Always turn it on. It's a great reference. It's a great way to help. Okay? Okay? Another thing really helps is to look through two of the scopes. There's a scope here and there's a scope here. Mm-hmm. Okay? So sometimes in daylight you're not able to see the laser, right? Try to see through this viewfinder first and then hone in with this one, okay? I would like you, I'll close this laser. I would like you to point at that camera on top right there, okay? Yeah, there's some focusing up you have to use as well. Okay, so now let's turn the laser on and see how accurate you were. Yeah, boom, right there, okay? And I want to introduce you to these two things as well. Obviously for crude movements, you can just move it around like this, no problem. But for finer movement, you can use this. See the fine movements there? So once you are crudely there, you can use these two knobs to do it, right? Okay, so I just want to take a moment to do the easy part first, which is the measuring with the laser, without the prism. What mode do you think I have to use it for that? Do I have to change it first of all?
You want the laser off.
Laser can stay on, no problem, but I don't want to use the prism. I want to use a measurement directly from the wall. Do I have to change the mode?
Yes, you do.
Okay, what do I have to do? Do I have to press that?
Yep, that's the one.
Okay.
To press.
Is this the one?
Nope.
Is this the one? Yep. Right. So now, to get the measurement,
Pitch and catch.
we just press either this button or look at that. The measurement is there, right? The S value, the vertical value, and the horizontal value. Now, does that make sense? Does that make sense that the vertical value is only 0.21? Mm-hmm. I think it does because it's measuring the vertical height from this point right here. See that dot there? Mm-hmm. The height is from this point to whatever we are pointing there. That's the middle of the TV. The laser is beaming, right? So that's 0.18 meter. Does that make sense?
Yep.
Okay, what if I go up there? I just increased 1.5 more meters or something like that, right?
Makes sense.
So does that make sense? It does make sense, right? But notice the horizontal distance, it should not move more than a couple of inches because we are only changing the distance from the screen
Right.
to the back wall, right? So the horizontal distance here is 8.250 versus 8.114 meter. Does that make sense?
Yep.
The S, which is the arm, what is the English word for that? You know, the triangle, the rise and the run, and what is the?
Oh, your hypotenuse.
Yeah, hypotenuse. I don't know why they call it S. S stands slope.
Slope.
I think that's what they're
Yeah.
going for, right? The slope will change drastically, right? Because we are changing the distance a lot, right? So 8.3. Here would be 8.3 again, but so this is a quick way to calibrate yourself that am I doing the right things or not? Is this making sense or not? Am I looking at the right object or not? This is a good way, okay? So we'll stop. It, as you can see, it's a continuous measurement.
Right.
It's beeping.
Yep.
When it's beeping like this, that means it's ready.
Okay.
Okay? We stop. Okay? That's so for example, if I want to do the entire length of entire height of a tank, right? So we focus it at the bottom, start the measurement, then we move up on the same line,
Yep.
only by touching this.
Okay.
Only by touching this, because if you move this way or that way, because it's changed now, because it's curved,
Right.
correct? So only by this line, we keep going up and up and up and up and up and keep recording the numbers. That's how we have a one linear profile,
Yep.
okay? So now we're gonna do the main thing, which is basically the prism mode, right? This is the mode we want, okay? Now, let's pull out the prism. The prism is right here. Let's take that out. Let's take the pole. There's a quick latch function right there. So for the quick latch, here, this is the way. You gotta pull this
Oh,
way,
oh, it
then
locks
press it.
It's locked,
There you go.
okay.
It looks
So-
a little bit loose, so let's tighten it up. So there must be no wobbly. This stick, it has to be solid.
Yep.
Okay. So okay. Now I'm just gonna hold onto this. Okay, so think about it this way, okay? We would like to measure all those points right here. We can probably point the laser here, no problem, right? But as we go further, that point gets obscured,
That's right.
right? Using the pole is basically elevating up here so that there's a clearer sight, okay? So that means we have to have the same constant height for everywhere that we go. Correct? Does that
Yep,
make sense?
yep.
So the only element that we have to be careful that it should be straight all the time, right?
Right.
So you should be holding it. I like to hold it this way with my both arms. I don't like to hold it like this because it's wobbly all the time, right? So the more relaxed you are, the better, right? So it's not gonna be perfect right there. Yes, I'm ready. Then the other person shoots and takes the measurement and writes it down. Okay, done. Go to the next spot. Center it. Ready. He jots down the number. Go down to the next spot. Ready. Writes down the next one. Okay? That's the process. Now I'm going to show you how to do the measurements, right?
Okay.
I think you should be able to do it yourself. Okay? So you just have to point it towards the laser. But I do want to show another function, another very useful function that we have. Once the laser is found, once the laser has found the crystal, it can lock onto it.
Okay.
You don't have to adjust it every time. It can lock onto it, and as you move around with this, it's just going to keep following it.
Okay.
There's the automated locking function, and I want to show you that part.
Okay.
Okay. So business as usual. We are in the crystal mode, right? Mm-hmm. We're in the crystal mode. Let's imagine that there's some darkness that you can actually see the laser. We're going to turn the laser on. Okay? Or we're going to adjust it with these two guys. And you're able to focus it in with this, right? You saw it very clear, correct? So when we're somewhat close, it doesn't have to be right on the money every time. Okay, you're there. You're there. The fella is holding it there, and you got it there, okay? Good enough. Then you got to hit this button right here, okay? Boom, it found it. And see, it's now latched on. Do you see that? Mm-hmm. You click it again to break the bond, okay? So again, we go somewhat close to it. I mean, there's no harm in finding it exactly. It doesn't have to be. As long as it's within that little area, it just makes it that much easy to find it. So I'm just going to say, like, maybe it's over there, okay? Then try to lock it down, lock it up, boom, locked, okay? Then we click this to measure the distance. We can click this, or we can click this. It's up to us, okay? It's doing its thing. It's doing the measurement, okay? Now this is the fun part I want to show you. You can keep shooting me. So I don't want to break the bond by walking across it, okay? Do you see this? Do you see this? Okay, but see, there's no constant beeping yet, okay? Now I'm at this position. You happy with the number? Write it down. Okay, done. Next spot. Not yet, not yet, not yet. Ready. You heard me, ready? So you write it down. Then you say done. Go to the next one. Okay, not yet, not yet, not yet, not yet. Ready. Then you write it down. Okay. Now I have to go somewhere that this guy cannot follow me. So break the bond. Here. Did you break the bond?
Yep.
Are you sure? Oh yeah. You can stop the measurement. Yeah. Oops, 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 oops. No, stop. Okay, done. Simple. For you, are you taking me? Video? Yeah. So another thing important, okay? If you go too fast, you're going to break the bond. If you go across and you cannot see it anymore, you're going to break the bond. So to save effort and energy, it's easy. The easiest way will be, okay, done, done, done. Slowly, 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 done. Because it just takes time to create that bond again, right? That's it. That's it. Okay? Now, I would like you to take 4 measurements of this plate at the 4 corners. Okay. I'm your helper. What are you going to do?
Very good.
Is it close enough? Boom. Okay. So what are you going to tell me? Tanzim, do what?
To the back corner.
Okay, let's call that station 1. Tanzim, go to station 1.
To station 1.
Okay. Ready.
Have to hit distance, right?
Mm-hmm.
One second. Tell me when you're ready.
Ready.
Okay.
You wrote it down?
Yep.
Which one? The H or the V or the...
The H.
No.
Oh, you want?
Vertical.
Oh, vertical? Okay.
Yep.
Yep.
Okay, now?
Okay. I'll move to station 2.
Ready.
Okay. Got it. 063. Okay, move to station 3.
I'm walking too fast. Tell me to slow down.
Slow down a bit.
Yeah. There you go.
Ready?
Mm-hmm.
Okay. Then back to station 4. Slow down a bit.
After this, I'm going to show you an example of a fast walking and how it breaks up.
Okay.
Ready.
Okay. 07.
So this is okay, hey? Even this, see, it broke now.
Right.
That quick motion, it broke, right? So let's break the bond there. Okay, done. Simple.
Okay.
Isn't it simple and fun?
Yeah.
Right? That's it. Okay, so now the same thing. I got my 3 stations. Okay, maybe this is my last station that you can see. So you're gonna ask the helper, you just stay there, or it doesn't matter. You take a break. Just make sure that you can come back on that exact same point, right? Maybe mark it up, right? You go to the new vantage point, set it up, blah 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 blah, do the measurement, and then write it down, right? So in the end, the minimum. We don't do less than 8. Okay, so we have station 1, station 2, station 3, 4, 5, 6, 7, 8. Okay. I rarely need more than 4. Let's just say that we will need 4 viewpoints, okay? Viewpoint 1, viewpoint 2, viewpoint 3, viewpoint 4. Okay? So you're going to have numbers, okay? 0.321, 0.322, 0.344. Okay? Probably you won't be able to see more than 3. Maybe you're able to see more than 4. Who knows, right? So the next station is going to have something in common, right? 0.291, 0.290, 0.289, and so on. Okay, so these 2 are common, right? Maybe you can see one more, who knows?
Yep.
0.291 again. Okay, then you go to the next station, right? So maybe here is back up to 0.420, 0.421, 0.419. Okay, as long as we get a staggered number and we have number for all the sites, all the stations, we're good.
We're good.
Okay.